We're going to introduce a new concept here. This is the concept of a logarithm. And really what a logarithm is, in its simplest definition, is an exponent. Okay, so a logarithm we need to think of as simply an exponent. Let me show you a couple of examples here. On your calculator, you're going to see that there's a button, log. You should find it on there. And then if you enter in on your calculator log of 100, you should see that that answer is 2. And if you entered log 1000, you should see that the answer is 3. Well, if we think back to what a logarithm is, that is really just an exponent, what this question is asking is what, so we'll call this question 1, we'll call this question 2. So if we look at question number 1 here, what it's saying is what would be the exponent on 10 that would equal 100. So in other words, what exponent on 10 would equal 100? And of course that's why the answer is 2, because 10 squared equals 100. And in question 2, we ask, what this is asking is what is the exponent on 10 that would equal 1,000? Well, that's why the answer is 3. Because 10 cubed is 1,000. So logarithm questions always ask, what is the exponent? That's the question. When you see log of 100, it's saying, what exponent of 10 will equal 1,000? Sorry, equals 100, which is 2. And down here, what exponent of 10 would equal 1,000? That would be 3. So we already know that log 100 is 2, because 10 squared is 100. What if we had to figure out what the log of 45 is? Well, we'd be asking ourselves, what is the exponent on 10? What power of 10 would be equal to 45? That's what this question is asking. Well, we don't really know what that would be. We can't do it in our head. We know that 10 squared is 100, so that's too big. And 10 to the power 1 would equal 10, so it's got to be somewhere between 1 and 2. If you go to your calculator, punch in log 45, and hit equals, you'll see that this is, to 2 decimal places, about 1.65. Logarithms don't always have to be base 10. These ones here, these 2 examples I gave you, were base 10. If the base is something other than 10, we usually then start to write the base at the bottom down here. You could technically write a small little 10 beneath here, but it's assumed if there's nothing written there that we are talking a base 10 logarithm. But here's another example. This is a base 2 logarithm. So again, a logarithm is just an exponent. The question would be, what exponent, when there's a base of 2, will equal 8? Well, if you think about this for a bit, 2 times 2 times 2 is 8. So in other words, 2 cubed is 8. So log base 2 of 8 is equal to 3. We'll look at these 3 examples. Log base 3 of 9. Well, that must be 2. Why? Because 2 is the exponent on 3 that would equal 9. So you see the relationship here between exponents and logarithms? A logarithm is simply the exponent. What is the exponent on this? That will give you this. Here's another one. So if you didn't know what this is, you could ask yourself, what is the exponent on 4? That will equal 1. Remember back to your exponent laws. Remember any number to the power of 0 is equal to 1? So this answer will be 0, because 4 to the power of 0 equals 1. How about these ones? You need to ask yourself, what is the exponent on 5 that equals 1 over 25. Again, if you remember your exponent laws, we know that 5 squared is 25, but since this is 1 divided by 25, the exponent needs to be negative. Remember, a negative exponent takes a reciprocal. So 5 squared would give us 25. We need the reciprocal of 25. So the answer, the exponent, would be minus 2. So just to review how exponents work and logarithms work, if we had log base a of b equals c, so in other words, as an example, log base 2 of 8 equals 3, okay, which is true because 2 to the power 3 equals 8. What does this mean? This means a, or this number here, b, let's say, b will always equal a to the power c, or in other words, 8 is equal to 2 cubed. So this is how we can take a logarithm and write it as an exponent. Okay, and sometimes we like to call this the back rule. So log base a of b equals c means that b equals a to the power c. So as an example, log base 2 of 8 equals 3 means that 8 equals 2 to the power of 3. So this is a really important rule. You need to make sure that you know how to take a logarithm and write it as an exponent, or to take an exponent and write it as a logarithm. So here's a simple example. Log base 2 of 8 equals 3. This is a logarithm. Here it is written out as exponent. 8 is equal to 2 cubed. Make sure you're able to use that formula to convert between one and the other.